Okay, this video is for page 121 in your binder for Chem 1. This is turning word equations into balanced chemical equation. So the first thing that we're going to do is look up on the TAN chart or the periodic table what antimony is. We're going to turn this into a balanced equation. So antimony is Sb. Okay, and it's a metal, so you could probably put a solid there. Reacts with chlorine gas. Now look at the bottom of your TAN ion chart and note that chlorine gas is Cl2. All right, it's a diatomic gas, so gas. Okay, now it's going to make solid antimony, so Sb, and it's Roman numeral 3, means that it's 3 positive ion, and chloride is 1 negative ion, so you got a crisscross, so SbCl3, and it says that that's a solid. Okay, so there's your equation, and if you look at that, you're taking two small things and putting them together to make one big thing. Okay, so that is a synthesis reaction. I'm just going to abbreviate that with a capital S. Okay, now we need to balance this equation. So I would look at the atoms on the left side. Well, there's Sb and Cl. That means the same types of atoms have to be on the right side. Okay, now we're going to count. On the left side, there's 1 Sb and 2 Cls. On the right side, 1 Sb, 3 Cls. Okay, so you see 3 and 2. You got to think, what do they both go into? They both go into 6. So we got to make this chlorine 6. So we got to think, what number times 2 makes 6? And that number is 3. So there, we've just changed that to 6. Now we're going to make this one 6. So we got to think, what number times 3 makes 6? That's 2. So now 2 times 3 is 6 chlorines, but now we have 2 antimonies. So we got to fix this side over here, so we'll put a 2 there. And that will make everything the same number on both sides. That's balanced. Okay, the next one. I kind of skipped down to number 7. And so aluminum metal, so Al is a solid, plus aqueous sulfuric acid, H2SO4AQ. That's going to yield aluminum sulfate. So now we're going to have to use the TAN chart. Aluminum is 3 positive. Sulfate is SO4. It's a polyatomic. So I'm going to put it in parentheses. 2 negative, and I'm going to crisscross. And it's a precipitate. That means it's a solid. And hydrogen gas, H2. Okay, if you've noticed this one, the aluminum and the hydrogen have basically traded spots. This is a single replacement. All right, let's balance this equation. So we draw a line at the arrow. Now I'm going to count the elements. So I have aluminum, I have hydrogen. Now here's a trick for balancing to speed things up. If you notice, SO4 is sulfate. That's a polyatomic ion. Well, there's also a sulfate over here. Basically, the polyatomic ion stays together. So instead of listing sulfur and oxygen, you can just list a sulfate. So over here we have aluminum, hydrogen, and SO4. Okay, let's count. We've got 1 aluminum here. We've got 2 hydrogens here. We've got 1 SO4 here. On this side, we have 2 aluminums, 2 hydrogens, and 3 SO4s. So I always like to try to fix the hardest one first. That sometimes helps. I got 3 SO4s on the right. I'm going to make 3 SO4s on the left by trying a 3 right here. Now it's important to use a pencil because sometimes you have to erase. Okay? Now that gave me 3 SO4s, but now that gives me 6 hydrogens. So I need to make this side 6 hydrogens, so I'm going to put a 3 here. That gives me 6 hydrogens because 3 times 2 is 6. Now everything's fixed except the aluminums. 2 aluminums here. I need 2 over here. So I got to put a 2 right there. And now that's balanced. Everything adds up to the same number. Okay, I'm going to skip number 3. You can do that one. It's pretty much kind of like number 1. Okay, Number 4. All right, calcium, or number 3. I guess this is number 3. Calcium chloride. So if you write that out, calcium is 2 positive. If you look at the tan chart, chloride is 1 negative. Crisscross, CaCl2. That's a solid. It's going to break down. Hey, that means it's a decomposition to calcium solid, CaS, and chlorine gas. Now, it's important to look at the tan chart again. Whenever you see the word gas, to see is chlorine a gas that exists by itself, or is it a diatomic? And if you look at the bottom middle of the tan chart, it is a diatomic. So that's Cl2, gas. Okay, so when you have one big thing breaking down, that's a decomposition reaction. Okay, let's balance the equation. So we got Ca and Cl, Ca and Cl. We count 1 Ca, 2 Cls, 1 Ca, 2 Cls. Hey, that one's already balanced. That was easy. All right, number 26. Solutions of strontium bromide and ammonium carbonate. So let's write this out. Okay, strontium is Sr. Now you could look on the tan chart or the periodic table, and you would find that strontium is 2 positive. Bromide is 1 negative, crisscross. Solution means AQ. Plus, ammonium is a polyatomic ion, NH4. Because it's polyatomic, I'm going to put it in parentheses, and it's 1 positive. Carbonate is also a polyatomic, and it's CO3. Now, it might help you to just start off by putting the polyatomics in parentheses. 2 negative. Now we're going to crisscross. 2, 1. Now, technically, you could erase the parentheses on the carbonate if you want to, all right, to finish it out. But anyway, okay, so this is a double replacement. Basically, we got a positive, negative, positive, negative. So basically, what's going to happen is the partners, like the strontium and the bromide, they're going to switch partners. Positives go with negatives. So the Sr, which is 2 positive, is going to go with the carbonate that is 2 negative. And if the charges are the same, but opposite, you don't have to crisscross. Okay? And I forgot to put AQ over here. Okay, now it's going to produce aqueous strontium carbonate, so that means that's AQ, plus ammonium bromide. So ammonium is NH4, and it's positive 1, and the bromide is Br1 minus. So positive minus, you don't need to crisscross anything. Okay, and that is a precipitate. That means that's a solid. Okay, now let's balance this thing out. Okay, so I have an Sr, a Br, I have an ammonium. Now notice that there's an ammonium here and ammonium here, so I'm leaving the polyatomic ion together. It just makes it easier to balance. And carbonate, CO3, CO3. Okay, on this side there's an Sr, a Br. There has to be the same stuff. I always like listing them right beside each other. Some chemists just make one list down the middle. I don't know, I like making 2 lists. But anyway, Sr1, Sr1, if you count. Br, there's 2. Br over here, 1. NH4, ammonium, 2. NH4 on this side, there's just 1. See, there's only 1 NH4. 1 carbonate and 1 carbonate. Okay, let's see what's not balanced. Well, I see this NH4 is not balanced, and I'm going to do that one first because it's the more complicated thing. I always like to do that first. So I'm going to put a 2 over on this side, and that's going to give me 2 NH4s, and it's going to now give me 2 Br, so I got to make an adjustment. Now I'm going to look, 1 Sr, 1 Sr, 2 Br, 2 Br, 2 NH4, 2 NH4, 1 CO3, 1 CO3. Okay. All right, that one's done. All right. And by the way, I don't think I ever said this on this one, This is what's called a double replacement reaction. Okay, that's it.